Okay. So, please stop talking. Okay, so today we're going to talk about segment postulates. Tomorrow we're going to talk about angles. Okay, and then Friday we'll get into the good stuff. Okay, so the first one is called the segment addition postulate that we're going to talk about today. So if you flip this over on the inside, we're talking definition first. Let me zoom in on this. Okay, so the definition says if we're given 2 points, A and C. So whenever you get these types of problems, I'd like you to draw a picture. It is so much easier to visualize it. So we're given 2 points, A and C. So here's point A, and here's point C. Okay, and they say that this is a line segment, which means you have a line that connects these 2 points. Okay, then it says we have a third point, B, that lies somewhere on this line, anywhere you want to put it. So we've got this random point B that's somewhere on this line. Again, anywhere you want to put it. It can be in the middle. It can be more towards the left, more towards the right. Your segment addition postulate says, if I take this tiny segment, AB, this is AB, and I add it to the segment BC, then the total is the whole piece altogether. Okay, so it's something like if my grand total was 12, I can have a segment that's worth 6 and another segment that is worth 6. If I add them together, it gives me 12. Okay, or I can break it up into 8 and 4. I can have a segment that's worth 8 and a segment that's worth 4. When I add them together, that still gives me 12. Okay, so 2 smaller pieces make the big piece. So let's do some examples of what you're going to see with this postulate. All right. Okay. So example 1 says, if C is between D and E. So the first thing you want to do is draw the picture that represents this. C is between D and E. So that means we have D on one side, E on the other, and C lies somewhere in between. So the biggest thing is being able to read this and comprehend what it's telling you, which is usually what most of you struggle with. So I really need you to take some time, stop, breathe, think as you're reading. Don't hyperventilate. Please don't do that. Okay, so it now tells us that DC is 1/2 times 4x plus 6. So this piece right here from D to C is equal to 1/2 times 4x plus 6. It then tells me my other chunk, C to E, so from here to here, is equal to 3x plus 1. And then the last piece it tells me is DE is equal to 44. So from the beginning to the end then totals out to 44. Okay, so that's what this looks like as a picture. We're going to have to solve for x. Okay, we need to find what x is. According to my postulate, if I take the 2 smaller pieces and add it together, it should be equal to my big piece. So my first small piece it's 1/2 times 4x plus 6. My second small piece, I need to add to that. So 3x plus 1. And that should be equal to my big piece, 44. Okay, the two smaller chunks that make up the big piece can be added together. Does everybody understand where I got that from?
Yeah.
Okay, we good?
Yeah.
Okay, so I need to solve this for x. Order of operations tells me I need to do what first? The parentheses. So what needs to happen? I need to distribute this 1/2. Okay, so I need to take half of 4x. Well, what's half of 4x? 2x. I also then need to take half of 6, which is 3. Okay, nothing else changes. So I still have 3x plus 1, and that's equal to 44. Now what? Combine your like terms. So I've got a 2x and a 3x that go together to give me 5x. I've got a 3 and a 1 that go together to give me 4.
Oh yeah, x equals 8.
Equals 44. X is going to equal 8.
Let's go.
Okay. What's my next step to get x by itself? Subtract this 4. Get rid of this 4. So we get 5x equals 40. My last step then? Divide by 5.
8, sir.
X equals 8. Okay. Be careful though. We're not quite done. Only because what does it actually ask you to find? DC and CE. So now that you know what X is, we need to find their values. So if I'm looking for CE, CE equals 3 times X, which is 8, plus 1. So what's 3 times 8? 24 plus 1 is 25. So CE equals 25. So it's not too bad. You just now need to take that and plug it back in. Okay. The last thing I need to find is DC. Well, DC equals 1/2 times 4 times X, which is 8, plus 6. Okay, so 4 times 8 is what? 32. What's 32 plus 6? 38. And what is half of 38?
18. Oh my God, bro. I'm messing up, bro. I'm messing up, I'm sorry.
What is half of 38? 19.
See, I was close.
Okay. If you cannot mental math that, you can easily plug this into the calculator just the way you see it, and it will do it for you. Okay. All right. Well, that's a good thing we're done, huh?
No.
Example number 2. Okay, again, start with what it tells you and draw yourself a picture. B is between A and C. So draw yourself a picture with A and C and put B in the middle. Okay, then it tells us that this segment right here from A to B is equal to 1/4 of 16x plus 24. It then tells us this piece right here that goes from B to C is equal to 7x plus 15. And our big piece is equal to 120. So again, we need to solve for x first and then go back and tell them what AB equals and what BC equals. So addition, segment addition postulate says I can add the two smaller pieces together and set it equal to the bigger piece. So this should look like 1/4 times 16x plus 24 plus 7x plus 15, and that should equal 120. Okay, so it should be the same steps that we did in the last problem. But this time when I distribute, I'm distributing 1/4. So I need to divide everything by 4 inside the parentheses. So what's 16x divided by 4? 4x. So we start with 4x. This also needs to be distributed to this 24. What's 24 divided by 4? 6. Okay, everything else just follows down in suit. Okay, now I'm going to group my x's together and group my numbers together. What do we call that? Combining like terms. So 4x and 7x gives me what? 11x. 6 and 15 gives me what? 21. Okay. Next step. Get rid of that 21. We need to subtract that 21. So we get 11x equals. What's 120 minus 21?
Boy, no.
99.
What you say? He's the best step.
Okay. Finally, my last step to get x by itself. Divide. When I divide by 11, I get x equals 9. Okay. So now we know x equals 9. We can go back and solve for these individual pieces. So BC is equal to 7 times x, which you just said was 9, plus 15. Plug it into your calculator. What's 7 times 9 plus 15?
70.
We all getting 78. Okay, so that's one segment. We also need to find out what AB is. So AB, again, that's equal to 1/4 times 16 times 9 plus 24. Okay. Okay. You've got two options when you plug this into the calculator. If you're going to plug it in straight the way you see it, please make sure you put in 1/4 in parentheses. You can also plug in the 16 times 9 plus 24, get your answer, and then divide that by 4. Okay, because timesing by 1/4 and dividing by 4 are the same exact thing. Okay, so you've got two options here. You got 42. We get 42. 42 should be your answer, my friend.
You all right?
Okay. So that's all there is to the segment addition postulate. You can take the two smaller pieces, add them together, and that gives you the bigger piece. Okay. We've got a segment bisector postulate. Oh my. That just sounded awful. Okay, think what does the word bi mean?
Bisexual. Well, no, two. Both.
Two. Okay, so bicycle, two wheels.
What the word bi mean? He said bisexual.
Okay, what does bi mean in math?
Okay.
Thank you. Okay, so your formal definition: a segment bisector is a line. Okay, so it can be a line. It can be a ray. What's a ray? Okay, so it can be a flat out line that looks like this. It can be a ray, which means it has a dot and an arrow, or it can be a segment, which means it has dot and a dot on both ends. Okay, so it can be a line, a ray, or a segment that's going to divide a line segment into two equal parts. Okay, so if I split a line into two equal parts, that means the left side and the right side are the same. Okay, so this will look something like this. You've got this line. Okay, and you've got a ray that splits the two. That means that this side, side A, and this side, side B, are equal to each other. Okay, so anytime it tells you anything bisects something, that even goes with what we're going to do tomorrow. Angle bisector. It is a line or a ray that splits an angle into two equal pieces. So let's do some examples that go along with this.
Hold that thought. Oh.
I'm sorry, did you need that back?
Yeah. I'll say hold that thought.
I'm sorry.
You good. Not any good.
Okay. All right. So if you go, we've got two examples to go along with this. So it says EF bisects AD. So that means AD is your original picture. So we've got AD. That's your original. And it says EF is going to bisect this. So EF is going to come down and it's going to cut line AD into two equal sections. So that means this piece and this piece are equal. Okay, and the way you can show that is a little line on each piece. That means that segment A, I'm sorry, it crosses at C, so this is point C. So that means AC and CD are the same because EF is your bisector. So both sides of that line AD are the same. Okay, and then fill in what they tell you. They say this section right here, A to C, is 5x minus 8. And then they tell you this section right here, C to D, is 16 minus 3x. And then when we go to solve, we have to make sure that we're answering the question. So it says find the value of x and AD. Well, I need to find x before I can do anything. Okay, so let's find x. If this is a bisector, we said that the two pieces are what? Equal. So we set them equal to each other. 5x minus 8. Absolutely, Elijah. They are congruent.
That's what I said.
Oh.
What? See, for me, that's in the
It
box.
sounded like it came from Elijah.
All right.
Elijah's back here like, yeah, I'm smart. I just said that.
That's not nice.
Whose glue's on the floor?
That's mine. I rolled it over there.
Why is it?
Boy. Okay. I need to solve this for x. What would you like to do first?
Combine.
Add 3. Okay. Remember, when I combine like terms, they have to be on the same side of the equal sign. So, Marlon, we can't start with combining terms. I only have one x and one number on one side and one x and one number on the other. So I need to cross that equal sign. Remember, when you cross the equal sign, it's always the opposite. So y'all told me to add 3x to both sides. So when I do that on the left, it goes with my 5x, which leaves me with 8x. This negative 8 just drops down. On this side, 16 drops down, and my x's cancel out. Okay, now what? Add my 8. If I move my x's to the left, my numbers need to go to the right. So I add 8 to both sides. 8x equals 24. And yes, x is going to equal 3. What do I need to do to make x equal 3? Divide by 8. Good. So x is going to equal 3. Well, we answered the first part of the question. Okay. Now we need to find AD. A to D is what?
Anthony Davis.
Yeah, they.
Okay. You can lump them together, or there's another way to do it. Okay. So let's just solve for AC first. So AC, we know is 5 times x, and we know our x is 3. And then we need to subtract 8. So what's 5 times 3? 15. Minus 8. 7. Okay, if AC is 7, and it is a bisector, so it is half of AD.
14.
AD is 14 then. So you could have plugged it in for AC and then plugged it in for CD. But if you know it's a bisector, that means this piece and this piece are the same. So we can take 7 plus 7 and make the whole thing 14. Okay. Either way, it would have come out to be the same answer. I like to do as much shortcuts as possible. Okay. Example 4 has the same picture. EF is bisecting AD at point C. So I've got A to D. And EF comes down and cuts it in half at point C.
Those are perfect. Bad, why you move?
Okay, be careful with this one. And again, this is why I tell you to draw the picture. When I fill this in, oh yeah, that should be AD. Sorry.
Anthony Davis.
Anthony Davis, who's that?
You hit to the
Basketball player.
No, he's not.
Okay.
He is a golfer.
So from A to C, guys, I need you to pay attention because this one's going to throw you for a little bit of a loop. Okay, that is a D. Okay, so AC, they tell you that this little chunk right here is 2/3 times 4.5x minus 1.5. What's the other piece of information they give us, though? AD. Okay, so they give you that this whole section is 12 minus X. So they don't give you the other little piece. So you can't set them equal to each other. That's a problem. So what are we going to do? We still have to find X. There's two different ways we can approach this. Take a look at it. Tell me what you think. Okay. Put what together? You can, but what's CD? We don't know what CD is.
Call for AC.
But how? Think about it. Okay, gentlemen, I don't know what you're talking about, but it's not about this. You need to stop.
All right.
What does the line EF do again? It cuts it in half. It breaks it into two equal parts. So, can I do this? Does that work? If the whole thing is 12 minus X, and you're telling me that line cuts it in half, well, that means C to D is half of the whole thing, right? So I can make CD 1/2 of AD. So I can simply say that CD is 1/2 of 12 minus X. Even though they didn't tell you what CD is, it's half of the entire thing. Well, if my entire thing is 12 minus X, that means CD is half of it. So now I can set them equal to each other and solve. So we've got 2/3 times 4.5X minus 1.5, and that equals 1/2 of 12 minus X. Okay, so the first thing I need to do is distribute this 2/3 through. So what is 2/3 times 4.5? It should be 3. Okay, remember when you plug it in, actually this one you won't need to put in parentheses because it'll do order of operations. So this should be 3x minus, what's 1/5 times 2/3, or 1.5 times 2/3? Negative. X. And what's half of -1? -1/2. I'm going to change it to 0.5 because you guys like to deal with decimals better than you like to deal with fractions. Okay, so that works. Okay, I need x's to one side, numbers to the other. What would you like to move? You want to move the 1, okay? I move the 1. That leaves me with 3x equals 7 minus 0.5x. Now what? Add 0.5. So we get 3.5x equals 7. Divide by 3.5, which means x equals what? 2. Okay, so it said find X and now find AD. Well, I know AD is 12 minus my X. So 12 minus 2 is 10. So you found X and you found AD.
No, this is when I was scared.
Because you actually have to solve the equation.
No, that's my favorite part of math. Solving equations. I hate that.
Okay, the last segment postulate or theorem we need to talk about is the midpoint of a segment. What does it mean to be the midpoint?
In the middle.
In the middle, which means what? If my point is in the middle, what does that mean for my left and right side?
They're equal.
They're equal. So this is the same beast that we've been dealing with, except they call it a midpoint of the segment. So instead of it being a line that's going to cut the segment into two equal segments, it's just going to be a point. So that means if I have something like AB and C is my midpoint, that means AC equals CB. Okay. AC equals CB. Okay. All right. So on this side, example 5, it says M is the midpoint of PQ. So draw yourself what that represents. So that means I've got this segment that goes from P to Q. And M is the midpoint, so M is your middle. Okay? It then tells me that from P to M is 1/2 of 10x plus 16. And then it tells me from P to Q is equal to 76.
Oh, God.
Okay. So we're back in that same issue with example 4. Where normally you would take PM and add it to M, or set it equal to MQ because they're the same. But this time they only gave us PM and then the whole thing. What does MQ equal if the whole thing equals 76?
38
How'd you get that?
divided 76 by
Okay, good. That means MQ is half of this. Well, if you take 76 and divide it by 2, that means MQ is 38.
38.
Which means PM, which is 1/2 times 10x plus 16, should equal 38. It should equal half of the whole.
Miss Smith, you know that's somebody's name?
What?
38.
Yeah, he becomes
His name is 38.
Cent, yeah.
like I'm like, who is it? 38. That guy says his name.
Interesting. So let's solve this. We need to distribute that 1/2. Well, what's 1/2 of 10x? 5x. What's 1/2 of 16? 8. And that should equal 38. Next step, Edwin. What do we do next to get x by itself? 5x plus 8 equals 38. I need to get rid of everything that doesn't have an x. So what do I do? Subtract what? What's being added Good, we subtract the 8. Subtract your 8 from both sides. You get 5x equals 30.
6.
How'd you get that?
Divide.
Divide by 5. Last step is divide by 5. X equals 6. So we answered the first part of the question. X equals 6. Now they want to know, what does PM equal? Hint,
38.
hint.
38.
If MQ equals 38,
It's 38.
PM equals 38.
Because it's B.
Right.
I'm playing with the
You didn't even have to solve that one.
Bro, I like this one better.
Beautiful thing. Okay, last one. M is the midpoint of PQ. Draw that pretty picture one last time. PQ. And M is your midpoint.
3Q.
This time they tell us that this little section here is 9x plus 3. And from M to Q, we have 11x minus 17. With the information that they gave us and what you know about midpoints, what do we need to do to those two separate expressions? Set them equal to each other because both sections are equal. So you end up with 9x plus 3 equals 11x minus 17. Our first step is to do what? You said subtract 9. Be careful, Joseph. You can't combine like terms unless you have more than one x on one side of the equal sign. So if you need to draw that line to make it make more sense to you, draw it. Okay. So Mr. Watkins says he wants to take the 9x to the other side. So we're going to have to subtract. So 3 equals 2x minus 17. If my x's are on the right this time, I need to move my numbers to the left by doing what? I need to move the numbers to the left. So add by 17, okay? So we get 20 equals 2x. Divide by 2. And x equals 10. Well, there's the first part. Okay. The last piece is asking, what is P to Q? So they want to know the whole thing.
If half of it is 10.
So let's figure out what half of it is. We don't know what half of it is yet. We know that x is 10. To find half of it, we need to plug it into one of these equations. So 9 times 10 plus 3 is what? 93. Okay, so 93 is the distance between P and M.
What?
So what is the distance between P and Q? Multiply it by 2 or add it to itself. So 93 times 2 is 186.
186.
Questions? Anybody? We good?